So we are looking at tab 2.3 in our foldable, and we are above the fold, okay? And today we're going to talk about the product and quotient rule. And the product and quotient rule are used when our regular power rule rules kind of fall apart and we meet certain criteria. And so the certain criteria we need to meet for the product rule is that we need two or more functions multiplied together. And we say that it is like we say h of x is equal to f of x times g of x. And the quotient rule is for two or more functions being divided. Keep in mind that the product rule is often applied to like 3 or 4 functions, although there's other tricks to getting yourself out of a lot of them. The quotient rule, that does not happen nearly as often. So for the quotient rule, f of x divided by g of x. So the quotient rule states that the derivative of h of x is equal to f of x times g prime of x plus g of x times f prime of x. And you'll notice that, remember that addition and multiplication, both order doesn't matter. And so because of that, it's okay if you make a mistake and you kind of flip-flop things a little bit. In division and subtraction, which is the quotient rule, order does matter. And so it's very important that you note that it is g of x times f prime of x minus f prime of x times g of x all over the quantity g of x squared. Okay, so let's talk about an example of the product rule. Okay, and there's lots of different types of examples that are out there, but we're just going to talk about one super simple. I shouldn't say simple because it's not simple. Okay, so we have the product of two things that when I went and used the product rule and multiplied and power rules, this might get a little bit more difficult. And so that's where things like the product and quotient rules become really helpful. So the first thing we need to do is identify the two terms that we're talking about. So f of x is the first term and g of x is the second term. And I'm going to rewrite this with fractional exponents so that when I go and apply the power rule, I'm more prepared. So g of x is x to the 3/2 plus 3x. And the derivative of g of x is 3/2 x to the 1/2 plus 3. And we used the power rule to do that. Okay. F of x is x squared plus x to the negative third. Again, I used some algebra tricks to rewrite that. And the derivative of that is 2x minus 3x to the negative fourth. Again, we used the power rule. Okay. So now we're going to apply our rules and find the derivative of h of x. So you'll notice we have f of x, so f of x squared plus x to the negative third times g prime of x, so 3/2 x to the 1/2 plus 3 plus g of x, so x to the 3/2 plus 3x times f prime of x, which is 2x minus 3x to the negative fourth. Okay. And finally, we're now going to simplify this equation, which again, many of you have heard me start to say, and I'll say it 1,000 times, this is a time when your answers become a lot more difficult. The calculus isn't so bad, it's the algebra. Sometimes you'll hear people say that calculus is 2 parts calculus and 8 parts algebra, because it's mostly your algebra that's required to get to the most simplistic Perfect answer. And in my class, I often refer to those answers as rockstar answers. I don't expect that each of you will get to a rockstar answer, but know that if you're in WebAssign or you have a multiple choice question, sometimes they require rockstar answers. And so it's okay. And it's okay if you struggle. And this is one of those times when if you were checking answers in the back of the book, I would tell you don't bother checking your answers in the back of the book because their answer is going to be this nice, pretty, beautiful thing, and your answer's not. Okay, so let's do this. So simplifying this becomes 3 halves x to the 5 halves plus 3x squared plus 3 halves x to the negative 5 halves plus 3x to the negative third plus 3x, nope, I lied, plus 3 plus 2, x to the 5 halves minus 3x to the negative 5 halves plus 6x squared minus 9x to the negative third. And so the good news is lots of these are like terms. So we have 5 halves and 5 halves, which gets me 7 halves x to the 5 halves plus x squared and x squared, which gets me 9x squared plus negative 5 halves and negative 5 halves, which gets me negative 3 halves x to the negative 5 halves and 3 to the negative third and negative 9x to the negative third, which gets me negative 6x to the negative third. And so that's not the most beautiful answer on the planet. I will admit to that, but it's not so bad. To write it as a rock star answer, okay, 7 halves times the square root of x to the 5th plus 9x squared minus 3 over 2 times the square root of x cubed minus 6 over x cubed. And there is your rock star answer. Reminder to you, kind of, if you're watching this video having taken the notes in class with us, not all my examples are exactly the same. So sometimes it's good for you just to practice the example question because it may not have been the same as your class question. Okay. While we're here, we're going to move over to the quotient rule now. So the quotient rule says, well, what is the derivative if h of x is equal to 3x plus 2 over 6x squared minus 7x plus 1. Okay, so first up, I need an f of x and a g of x, and we'll highlight them in the same color. So f of x is going to be yellow again, and g of x is going to be blue. So my g of x is 6x squared minus 7x plus 1, and my g prime of x is 12x minus 7, and my f of x is 3x plus 2, and my f prime of x is 3. So let's go ahead and put together my derivative. And remember, this is a quotient, and so order is going to matter. And we're going to need to make sure we're very cautious with how we go about this situation. So it is the bottom, so g of x, so 6x squared minus 7x plus 1 times 3 minus 12x minus 7 times 3x plus 2 all over 6x squared minus 7x plus 1. So go ahead and simplify the numerator. We're going to go ahead and simplify the numerator. And we're not going to touch the denominator. We're not going to make it any cleaner because it's as clean as can be. And as you get into kind of further some of the units here, you'll see that there are some tricks that might allow you to eliminate the denominator or parts of the denominator, which we did in rationalization and fractions before. And if you distribute as you saw back then, you miss kind of seeing some of these things. So let's do this. 18x squared minus 21x plus 3 minus 36x squared plus 24x minus 21x minus 14 all over 6x squared minus 7x plus 1 squared. Okay. And combine like terms. This one's not nearly as disgusting. X squared minus 18x squared minus 36x squared is negative 18x squared. Negative 21x plus 21x minus 24 is negative 24x. And 3 plus 14 is 17 over 6x squared minus 7x plus 1 squared. And there is your rock star answer.